Thank you. All right. So what are we doing today? Today we are going to, we got a short period. So today what we're going to do is we are going to solve these quadratic functions. And how do we know they're quadratic? Because the highest exponent is a 2. So we are going to solve these quadratic functions, right? We're going to solve them algebraically. And then we're going to check our solutions graphically to see that we did the thing right. Are you guys with me? Mm-hmm. All right. So what I'm going to show you today is not how to solve it, because you know this part, right? But what I am going to show you today is how to graph it. So I want everybody to flip your paper over to the back. And I want us to start with the very first function that we have on the paper. So our very first function was y equals 2x squared plus 6x plus 4x plus 12. Just oblige me real quick and tell me, what is this in standard form? Can I simplify this? Yeah. Yes. Tell me what I would write. Y equals what? 2x squared plus 10x plus what? 12. Now, let's go here. Let's go ahead and flip back over. Let's start with this real quick. So we got y equals 2x squared plus 10x plus 12. What am I going to do? So this is my standard form, right? So y equals 2x squared plus 10x plus 12. Can you identify for me my A, my B, and my C? What is my A? 2. It is just 2. It is not 2x squared. It is not 2x. It is just 2. Why? Because A is always the coefficient of x squared, right? What is my B? 10. And what is my C? 12. Now, when I look at this, before I even start to do any of this, let's look at the concavity. We talked about last week or earlier this week about concavity, right? Mm-hmm. Our concavity is determined by our A, right? Mm-hmm. If our A is positive, we concave up and therefore have a minimum. That's that lowest point. If our A is negative, we concave down and therefore have a maximum. So if I look at my A, it is what? Positive. Am I going to concave up or down? Up. So that's my first answer. I concave up. Now, is my vertex going to be a max or a min? Minimum. It's going to be a minimum. Do we understand why that is? Yes. Yes? If I U up, what's on the end of both of these lines? Arrows, which means they keep going. So is there a maximum? No. But there is a what? Minimum. So that's how we look at that. All right? Now, the other thing that we talked about was our shift, right? How do we determine the shift? Anybody remember it? It's in your notes. Let's go. What do we do? What do we do? How do we determine if we're shifting left, Keshley, or shifting right? Positive would be left. Negative would be right. But what are we doing to get positive or negative? The AB. What does AB mean? If I got two letters side by side, what am I doing? Multiplying. So when you take your A and you multiply it by your B, if that A times B come out to be positive, then we have a shift to the left. If that A times B come out to be negative, then we have a shift to the right. Thank you. Is everybody following? Yes. So I'm looking at my A. It's positive or negative? Positive. What's my B? Positive. What's a positive times a positive? Positive. So my AB is going to be positive. So which way is the vertex going to shift? Left. So that means when I look at a graph and you got the y-axis, where do I expect to see the vertex? On the right side of that or on the left side of that? Left. Is everybody following? Yes? All right. So that gives me some clues. So that's going to be a left shift. It is the shift of the vertex. Now I want to go a step further. I didn't put this on the paper, but I want you to write y-intercept, because we should be able to determine what our y-intercept is from this graph. What part of standard form gives me my y-intercept? C. What is our C? 12. So where's this thing going to cross the y-axis? 12. At 12. So now I got some clues. If I was asked to pick a graph, I would be looking for a graph that U's up, a graph that has a minimum, a graph that is shifted where the vertex is to the left of the y-axis, and it would be a graph where the parabola goes through the y-axis at 12. That's how I would identify that. Is everybody following? Charles? Okay. All right, so we just did this. I want to now, let's factor real quick, and then we'll go ahead and solve it. So I'm going to erase this because I already put it here so I can have this space up here. So what do you always have to plug in your first box?
2x.
The first term, right? Which in this case is 2x squared. What do you always have to plug in the last box?
Your last term.
Your c, which is what? 12. What if I don't have a c? 0. Right? Now, what goes here?
The middle.
In the middle. It doesn't matter. You can put 6x here, or you can put 6x here and 4x in the other box. It doesn't matter. So I'm just going to pop them here. I'm going to put 6x and positive 4x. Is everybody with me?
Mm-hmm.
Yes? All right. Now, let's talk about what we got. How am I going to get 2x squared?
2x times.
So does it matter if I put 2x here or here?
No.
No, put it somewhere. It doesn't matter. 2x and x. Is everybody with me?
Mm-hmm.
Yes? Now you just do the multiplication. What am I looking for? Factors. What are factors? Numbers that you multiply to get a product. It is your base and height that you multiply to get your area. So how do I get an area of 6x? X and what?
3.
X times 3 gives me 6x.
No, 6.
X times what?
6.
6. This I don't want to see. Why? Because it's just 2x and then a 6. This is not a factor. What kind of 6 was that? What kind of 6 was that? So I should see plus 6. Now what have I created? I created a factor. 2x plus 6 is the first factor. Are y'all following me? All right. Now I'm going here. 2x times what is going to give me 4x? What kind of 2? Positive 2. Now this is my second factor. This is my first factor. Is everybody following?
Yes.
Yes. What are factors? They are numbers you multiply to get a product. Now I want to show you something real quick. I know you may not have space on your paper, but I want to show you something real quick to show you that I'm proving that what we got here is what we should have, right? Watch me put this in a box real quick. I'm going to take 2x. Why you're not working? I'm going to take, so our factor form will be y equals 2x plus 6 times x plus 2. Everybody agree?
Mm-hmm.
That would be our factor form. Now watch this. Listen to me carefully. This is factored form. However, it is not factored completely. I'm going to say it again. This is factored form. However, it is not factored completely. How do I know it's not factored completely? Because if it was factored completely, this would be the form. Y equals A times x minus p times x minus q. I got one part and the other part, but I'm missing the what? A. So there is no number that's sitting out front, so this thing is not factored completely. Are y'all with me? I'm going to move you from regular factor to show you factor completely, but both of them are going to get you the same answer. So if you just simply factor, like we just did here, without factoring completely, it's still going to give you the right answer as far as your solutions. Is everybody following? Mm-hmm. Yes.
Where do you get P and Q from?
Because that's our factored form. It's right here, baby. Factored form. P, Q. Okay? All right, so let's go back. Watch this. I'm about to factor this completely. When something is factored completely, you're pulling out the greatest common factor. That means they don't have nothing else in common. I want you to think, does 2 and 6 have something in common? What factor, remember factors are numbers that you multiply to get a product, what factors do 2 and 6 have in common? So 3 can go into 2 evenly?
No.
What factor do they have in common? 2. Can't 2 go into 2x? Can't 2 go into 6? So that's the common factor. So watch this. I'm going to pull out a 2. Y'all with me? If I pull a 2 out of here, when I say pull out a 2, that means I'm dividing by 2. When I say pull out a 2, what am I doing? Dividing by 2. If I divide a 2 out of 2x, what is that going to leave me? X. If I divide a 2 out of 6, what is that going to leave me? Y'all just, all kinds of numbers. Yes, yes, all of those. Let me help you with the math. 6 divided by 2. 3. This is multiplication and division, not addition and subtraction. And then I'm just going to write my other factor that I got here. Just like that. Are y'all following?
Yes.
Why was I able to pull that 2 out front?
Because it's factored by both of the numbers.
Exactly, because that's a factor that falls into both of the numbers. Are y'all with me?
Mhm.
Is there a factor that falls into 1 and 2? Because the imaginary coefficient on that x is a 1, right? Is there a factor that falls into 1 and 2 other than 1? Can you divide 1 by 2 evenly? No. There's no other number that they got in common other than 1. So therefore, this is already, I'm good with that. Are y'all following me?
Mm-hmm.
But now this one, they got a 2 in both of them. So I can pull that 2 out, and now I have factored completely. Are y'all following me? Notice what my A is now. What's my A?
2.
It's a 2 out front. Does that make sense? Is everybody with me? All right, so now, what do I want to do? I want to show y'all real quick off to the side how I am able to prove that this is the right factor. So just watch me do this. Y equals 2x plus 6 times x plus 2. I'm going to use what's called distributive property. We familiar with distributive property?
Mm-hmm.
Right? So I'm going to take this number, because this says this times this. That means I can multiply this by this, and then multiply this by these two. And I should get my product that I started with. So watch. I'm just checking to prove that I factored correctly, because if these two are my factors, they should give me my product. Are y'all with me?
Mm-hmm.
All right, so let's do it. What do I have? Y equals, what's 2x times x? 2x squared. What's 2x times 2?
4.
4x. What's 6 times x?
6x.
6x. What's 6 times 2? 12. Same or different from my original? What is it? Same. So what did that just prove to me? That I factored correctly. Is everybody following me?
Teachers and students, please pardon this interruption. We are now in our tornado drill. Please shelter in place. Again, this is our tornado drill. So please shelter in place. Thank you.
I already paused it. I paused
Oh,
it.
you already paused it?
All right, so here we go. Baby, just get another one. Let's go. Let's go. Let's just go. Shh. I'm recording. Can you stop it and start back? Because we had to deal with a sidebar. Just pause and pause. All right, so do you guys see how I checked to see that my factored form was the right factored form? Yes? Okay, so I'm just going to erase this because I want to use this space for solving. All right? So now, when we solve, what is the solution to a quadratic function? The solution to a quadratic function is the x-intercept. How do I know I have an x-intercept? Because the y is going to be 0. How do I know I have a y-intercept? Because the x is going to be what? 0. So when you're looking at that ordered pair, if you have an intercept, one of them numbers is going to be a 0. If the 0 is with the y, then you have an x-intercept. If the 0 is with the x, then you have a y-intercept. But the solutions to a quadratic function will always be the x-intercept, right? It is the point where your parabola crosses the x-axis. Are y'all following me? So what are we doing right now? We're solving to see where our parabola is going to cross the x-axis. It can cross it once, it can cross it twice, or it cannot cross it at all. Are y'all with me? And let me just show you that real quick. If I had 3 graphs, right? It could cross it, it could hit it once. It could look just like this. How many solutions? 1. Or it could look like this. How many solutions? 1, because it only touches my x-axis 1 time. Y'all with me? What else could it be? It could go through it twice. Y'all see that? It could do something like this, right? But it's going to hit the x-axis twice. If you come out with 2 answers here, it has 2 solutions. If you come out with 1 answer, both of these will look exactly the same. When you solve them, it's going to give you the same number twice. So that means I only really got one. The same thing happened twice, right? Then you got what? You got where you could have
No solution.
no solution. Why? Because the thing ain't touched at all. Point. This is a vertex, but it's also your solution. When does that happen? Only when you have one solution, that's what's happening. Y'all with me? Your vertex may be your solution. Now, when you're here, you got two solutions. That is different from your vertex. This is your vertex. This is your vertex. Are y'all with me? Solutions aren't always vertexes. Are y'all with me? Or vertices, right? And then here, this is my vertex, but I have no solutions. Why? Because it never touched the x-axis. Are y'all following me? If it U down, how many solutions? None. But I always have a vertex. Is everybody following? Vertexes are different from solutions. Sometimes they're the same thing, but most times they're not. Is everybody clear? All right, now let's solve this problem. So how do we solve? We are going to set these equal to 0. Why? Because the zero product property says, if you're saying okay, when I want to find the x-intercept, I'm going to plug in a 0 for the y, and then in place of this y, you put a 0, that's the zero product property. Why am I saying zero product? What does product mean? Answer to multiplication. So the only way I got this 0 is by multiplying two factors. Are y'all with me? How do you get a 0 multiplying two factors? One of the factors gotta be a what?
0.
That's the only way. This can't be some number not a 0 and this another number that's not 0 and get 0. That'll never happen. The only way you get a 0, either this has to be 0, this gotta come out to be 0, or they both have to be what? 0. So what are we gonna do? We're gonna set each one of them equal to 0 and see which one makes sense for us. Are y'all with me? So how do we do that? I know this gotta be 0. That means when you take 2 and multiply it by some number and add 6, it gotta give you a 0. That means when you add 2 to some number, that gotta give you 0, right? So let's see what that number is that's gonna make both of these a 0. So I'm gonna do this. 2x plus 6 equals 0. And then I'm gonna do x plus 2 equals 0. What am I doing right now? I am trying to find the x-intercept. How do you get the x-intercept? You plug in a 0 for the y. Draw my squiggly. Work it out. Easiest part of the whole process. Subtract 6 from both sides. 2x equals negative 6. Last step. Divide both sides by 2. X is going to equal negative 3. What does negative 3 represent for me? A solution. Give me another name. A root. Give me another name. Is it the product?
A 0?
It's a 0. Or it's your solution, it's your 0, it's your x-intercept.
Your root?
Did I say root?
No.
Yes.
Root. Root, solution, 0, x-intercept. Are y'all with me? Now, we're going to do what over here? Emma, your hand was up. What's your question, baby?
So for the y, is it always going to be a 0?
When do I make the y a 0? And why? When do I make it a 0? When I am solving. What am I solving for? The x-intercepts. And what is always the y when you're trying to find x-intercepts? That's why I'm plugging in 0. Okay? So now let's go minus 2, minus 2. What happens to these people? Cancel out. X equals what? What is negative 2? It is a solution. What else is it? It is a root. What else is it? It's your x-intercept. What else is it? It's your 0. How many zeros do I have? 2. Where is this parabola going to cross the x-axis?
Oh, wait.
We should know this. This is what we just did. Where is this parabola going to cross the x-axis? Wow. I didn't say how many times. That's true. It is going to cut it twice. But where? If y'all don't know where the parabola is going to cross the x-axis, then we don't understand why I'm doing what I'm doing. What am I doing? What is this? Am I just trying to get numbers? What is this? Where specifically is my parabola going to cross the x-axis? Where on the side? At what?
What?
My parabola is going to cross the x-axis at what?
Negative.
Zero, wait. Negative 3.
Negative 3. Negative 2.
Keep going, Javea.
Negative 3, 0, and negative 2, 0.
Absolutely. Clap it out for her. Excellent. Where is this parabola going to cross my x-axis? At negative 3. At negative 2.
I didn't say that.
At negative 3. And at negative 2. Why? Because those are my x-intercepts. That's why we're solving this. What are we looking for? The solutions to a quadratic function. What are the solutions to a quadratic function? Y'all just gave them to me in 4 different ways. The x-intercepts, the solutions, the zeros, the roots. Okay, well, what is that? These two. These are solutions. These are our x-intercepts. These are our roots. Are y'all following me?
Mm-hmm.
This is where my parabola is going to cross the x-axis. How many solutions am I going to have? 2. How many times is my parabola going to cross the x-axis?
2.
Twice. Where is my parabola going to cross the x-axis? At negative 3 and
Negative 2.
at negative 2. Is that on the left or on the right?
Right.
Negative 3 and negative 2 is to the right of the y-axis?
No.
What did we circle?
The left.
Did we circle the left?
Yeah.
Where is it going to cross? Where's negative 2? Here's the y-axis. Where's negative 2? On the left. Where's negative 3?
On the left.
On the left. This thing is going to U on this side. Negative 2, and negative 3. It's going to go through those 2 points. It's all about the U. Absolutely. Is everybody following? Let's skip. Let's go down to, let's go on the back. What is our function? Y equals
The factor version or
both. Give me both. Give me the standard form.
y equals
2x squared
plus 10x
plus 10x
plus 12.
plus 12. Okay, now give me the factor form. Y equals
2 plus
2
2x plus
times, oh no, we didn't pull it out, did we? 2x
plus 6
plus 6, we did, but she gave me the other one.
times
Times what?
x plus 2.
X plus 2. Pay close attention. Are these two the same or different?
The same.
Same. It's just one in one form, the other one in the other form. But they are the same thing, Charles. They are the same thing. Which means when I am trying to find my y, look what it says. It says if you take 2 multiplied by x and add 6, then take x and add 2, and you multiply those together, it'll give you the y. Isn't that what that says? It says if you take x and you square it and multiply by 2, then take x and multiply by 10, and then add 12, add all 3 of them together, it's going to give you the y. So if I want to find out the y's, why do I want the y's? Because I want to be able to plot these points. And to plot points, you need a x and a what? Y. I need an ordered pair. If I am trying to find points to plot, then I can plug in x's into one of these rules, don't matter which one, get my y, and once I get my y, I got my ordered pair, plot the points. Y'all with me? Calculator's ready, because I don't want no wrong answers on these computations. So let's go. Work with me. I want to start with, if we look at this, right? What numbers am I going to plug in? I'm plugging in x's, right? Thank you, sir. This is the x-axis. This is the y-axis. What do you notice about the x's? They go from -4 to what? +4. Does it make sense for me to plug in a 5 as a -6 as an x? Because I can't graph that. It ain't on my coordinate plane. Right, Virgil? It doesn't make sense for me to plug in a number smaller than -4. It don't make sense for me to plug in a number bigger than 5 because I'm not going to be able to plot it. Right? So what do I want to do? I want to pick the numbers that are here and plug them in and see what I get. Right? So I'm going to go here and I'm going to plug in a -4. I'm just going to start and see what it gives me. Right? If I plug in -4, let me pull up my calculator, because if I plug in -4, I can plug it in here, or I can plug it in here. I want to show you both. Are y'all with me?
Mm-hmm.
Calculators. Let's plug it into this first one. What am I going to put in the calculator? If x is 4, -4, what am I going to put? 2 times
4.
2 times 4 plus or minus equals. What do I get? So I'm going to put right here, I just plugged into this top one, I'm going to put -8 plus what?
6.
Plus 6. Plus 6 equals, what do I get? So I'm going to put -2 right here. Watch what I do. That's this part. We just got -2 from this, right? Now I'm going to go here. What am I going to plug in? Again, my x is -4. So what am I going to put? -4 plus 2. So I'm going to put 4 negatives plus 2 equals. What do I get?
-2.
So here I'm going to put -2. Now what do I have? -2 times, because aren't these two being multiplied? So -2 times -2. So I'm going to put -2 times -2. What do I get? 4. So when I put in a -4 in my function for x, I get out a 4 for my y. So what is my ordered pair? -4, 4. Is everybody with me? All right. So then what am I going to do? I'm going to, starting at 0, I'm going to -4, 4. Where do I go? All the way up to 4?
No, you go.
Where do I go?
To the left.
To the left 4, and then what?
Up.
Up 4. So this is my first point. Is everybody following? Yes? All right. Now, several things could be happening. Is this parabola Ewing up or Ewing down?
Up.
Up. So I'm going to assume it's going like this. Are y'all with me? Yes? But let's see. It can't be doing this, right? Because the parabola is positive. So it's Ewing up, right? Okay, so let's do another point. Give me another point. Something. Give me a point we want to try. Would we do -6?
-2.
Why not -6?
It's not on the line.
Because it ain't on our graph. We're not going to be able to plot it. So let's pick numbers that are along here.
-2.
-2 right here. Let's do -2. Matter of fact, hold your thought. I wanted to show y'all how either one of these would give me the same thing. Clear your calculator. Do this. Put in your calculator, if we plug in -4 for x, I'm going to put x squared. How do I do that? 2 plus or minus. Oh, I'm sorry, not 2. What are we doing? 4 plus or minus, right? Then I'm going to square it. How do we square it? X squared. Y'all see that key? Hit x squared. Then I'm going to do what with it? Do y'all see what I just plugged in? I plugged in -4 here. -4 squared gave me 16. Now I'm going to do what? Times 2. Y'all, this middle school math now. Come on.
32.
Times 2. What do I get right here? So I'm going to put 32. Stay with me. 32 is this part. Now what am I going to do for this part?
The same thing.
But what am I going to put in the calculator? 10, because that's what it say, times what?
-4.
What am I?
-4.
We doing this first one. What am I putting here?
-4.
So I'm going to put 10 times 4 negative equals, what do I get?
-40.
Minus 40. Then what? Then what? We did this, we did this. What's next? Plus what with a 12? Plus 12. So I'm going to write that down. Right? This came from here. -4 squared. You got to do exponents before you do multiplication. Times 2 gave us 32. 10 times -4 gave us -40. 12, 12. Now, I'm putting my calculator, everything. What am I putting in? 32 minus 40 plus 12 equals, what do we get? See how you get the same answer? So, does it matter which form you use? No, it's up to you. Right? All right, so I just wanted to show you that. Now let's do this -2. So what are we going to do? Y'all want to use the factor form or the standard form? Okay, let's do standard because we did factor the first time. So let's do standard. If I plug in -2, what am I going to put in the calculator? First. -2, so 2 negatives.
Squared.
Squared. Don't forget to square it. Then what?
Times 2.
Times 2 equals, what do I get?
8.
8. Then what? What's the next part?
Negative 2 times
10 times
negative 2.
times 2 negatives equal, what do we get?
Negative 20.
Minus 20. Then I'm going to do what?
Plus 12.
Plus 12. Just bring the 12 down. Plus 12. Now, let's put it in our calculators. What do we got? 8, take away 20, plus 12 equals?
0.
Oh. What's that ordered pair? Negative 2 what? Now I want you to look at that for a minute. Because what is the y on that?
0.
And when the y is 0, that means we've just found a what?
Solution.
A solution. We've just found a x-intercept. Are you guys with me? Let's plot that point. Negative 2, 0. Where am I going? Remember, these are going by quarters. So I'm going to the left. This is 2, so that means this is 1, and this is 3. Y'all with me? All right, so I'm going back 2. Back 2, and up what?
0.
0. So I'm staying here. Are we starting to see the form?
Yes.
This thing is going to go down here and do something, right? So what number we want to try next?
3.
3.
Okay, we can do negative 3, but watch this. If you do negative 3, which we can, isn't it just going to create another point on this side?
Yes.
Don't we want to kind of see where this thing goes over here?
Can we do
So let's do a number on this side to see where it uses up.
positive 3?
Oh, so you think this parabola going to go all the way over here? I like 0. Let's see what we get with 0. Plug in a 0. If we plug in a 0, which one we want to use here?
Factor.
Okay, let's use factor. So if I plug in a 0, what's 2 times 0? What's 0 plus 6?
6.
So my first number is a 6 times something. If I plug in a 0 here, what's 0 plus 2?
2.
2. So now I got 6 times 2. What does that give me? 12. Okay, so this is 0, 12. So wait, 0 gonna be all the way up to 12. Y'all see that? So that means this parabola came down, the U back up, and I went all the way up there. Are y'all following me? That's off my graph. So what do you think I want my next point to be? Do I want it to be to the right of 0? Or do I want it to be to the left? If I do a point to the right, isn't it just going to be further up than 12? Right? If 0, 12 is the next point, that means it went down and came up and went all the way through here. At 0. The further I go to the right, is the y going to be higher or lower? Higher. So do I really want to pick a point over here? No, I want to pick a point to the left. So let's pick something more to the left since 0 is off our map. Negative 1. Let's do negative 1. What do we want to do with negative 1? Want to plug it in factored, or you want to do it in standard? Standard. Okay, let's go. So negative 1. What is negative 1 squared?
1.
Come on, people.
1.
Y'all got the calculator, no guessing. What we got? Negative 1 squared. That's negative 1 times negative 1. 1. Very good. What's 1 times 2?
2.
2. So this is going to be a 2. Right? Now, 10 times negative 1. What's that going to be?
10.
Going to be what?
Whoa.
Be careful with your signs. What's 10 times negative 1? Okay, let's do it here. 10 times 1 negative equals what?
Negative 10.
You got to get them signs right, otherwise you're going to get the wrong numbers here, right? And then the last thing I'll bring down is a 12. So give me a, what do we do? Plug it in. What do I get? 2 minus 10
4. You get 4.
plus 12. What do we get?
4.
4. Ooh, didn't I have 4 before?
Yes.
So what is that telling me? If you got a 4 over here already,
Up.
and now you're getting a 4 over here, isn't that your parabola wrapping around? All right, so I got a 4, so what is it going to be? Negative 1 comma 4. So let's go back here, and I'm going to go left 1 and up 4. Look at this. My parabola is bending. Are y'all with me? Now, is this point my vertex?
Yes.
Here's how I know this point is not my vertex. Watch this. Because what does a vertex have in the middle of it? A line of symmetry. which divides your parabola in half. So this point is 1, 2, 3, 4 points away. This one is only 1, 2 points away. Can that be your vertex?
No.
Can't be. Vertex sits in the middle. So I know that can't be my vertex, right? So let's figure out what this vertex is, right? Now, one way I could do that, just to show you real quick, this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 places away. What's 6 divided by 2? So that means 1, 2, 3, 1, 2, 3. That means my vertex should sit right here. Are y'all following me? How do I know that? Because you got 2 points on the same line. That means your parabola, this is the symmetry. Y'all with me? So technically, this is where my axis of symmetry should fall. Because it's always in the middle. Are y'all following me? Let's do another point. If I know that this is the middle, give me another point we want to use. Let's do -3, right? So let's do -3 here. What do we want to put it in? Factored form or standard form?
Standard.
Okay, so let's do it. -3 squared. Help me out, people. What -3 squared gonna give me? 9. What is 9 times what we got? 2? 18. So -3 squared, -3 times -3 is positive 9. 9 times 2 is 18. Now I'm here. -3 times 10. -30. And then I just bring down
12.
plus 12. So what am I putting in the calculator?
18 minus 30.
18 minus 30 plus 12. What we get?
-0.
0. What did I just find? The other x-intercept. I just found the other solution. So what is this ordered pair? -3, 0. So I'm going to go back to my graph, and I'm going to go back 3, put a point. Now, don't that make sense? Because don't this line go right in the middle of -2 and -3? Yes?
So how come before when I said -3 you didn't do it?
Because I didn't want us to build this side yet. I wasn't ready yet. But I knew it was a solution. All right? I wasn't ready for us to see the solution yet. Are we all good here? Yes? Now, where's the vertex? Above or below this line? So the vertex up here?
No.
Where's the vertex?
On the line.
It's below. It's going to fall somewhere under these two, right? Because this parabola is going down and then it comes back up here. Are y'all with me? Notice this. How far is this line from here? Half a space. How far is this point from here? Half a space. So I know this is my axis of symmetry. Are y'all with me? Now let's find one more point. What number can we put in? Let's figure out what his vertex at. Can we figure out what a vertex at? How low this thing goes? Let's do, what is this point right in the middle?
A fraction.
A fraction. What is it?
1/2. 2.5.
-2.5, right? So let's do that. What does -2.5 look like as a decimal? -2.5. Because it's right between them two. Do me a favor. Put this in your calculator. For those of you that are wondering where we got that from, I want you to put this in your calculator. Put -3, because that's a -3. 3 negatives. Y'all with me? You ain't doing it. You doing it? Plus -2. So 2 negatives equals, what do we get? But I don't want that. I want what's in the middle of them. So I'm going to divide it by 2. What do you get? That's my vertex. It's going to be on -2.5. Are y'all with me? Is everybody following? Yes? Now, I'm going to go right here and I'm going to put -2.5. Let's figure it out. What do we do? Y'all want to put it in factored or standard?
Standard.
All right, so let's put this in standard. So what we going to do? -2.5
squared.
2.5 squared. -2.5 squared. So 2.5 squared. Hit that key. And then do what with it? I ain't telling y'all.
Huh? What happened?
I plugged in -2.5 in standard.
Times 2.
Now I multiply it by what?
2.
Times 2. Everybody should know this at this point. So what are we gonna get?
12.5
12.5. Now what am I gonna do?
minus 25. Oh,
What am I gonna put in the calculator? From left to right, what do I put in?
negative 2.
Start with this.
Oh, 10
10
times
times
negative 2.5
2.5 negative equals, what do I get?
negative 25
Negative 25. And then what's the last thing I'm gonna do?
plus 12.
Plus 12. Right?
Mm.
Everybody good?
Mm.
Now what do we do?
Out of
In our calculator. Yep. 12.5 minus 25
plus 12.
plus 12.
0.
We get what?
Negative 0.5.
Negative 0.5. So what is going to be that ordered pair to represent our vertex? Negative 2.5, negative 0. What? 5. Negative 2.5, negative 0.5. Right?
Mm-hmm.
Y'all with me?
Mm-hmm.
Now, let's go here on our graph. Negative 2.5. That's going to be back 2.5, but we already knew that. Y'all with me? And then down a half. Well, this is going by, this is negative 1, this is negative 2. So where's a negative half? In between 0 and negative 1, right?
Yeah.
So this goes here. And now, don't we have our parabola?
Yeah.
We got enough points. So now I could just curve this thing on out. And there's our parabola. And unless they tell us otherwise, that's what happens. We just graphed this. Yes.
How come it's not on the right since you said right is negative?
Nope. Right? No. We said A times B, when it's positive, your vertex is going to be on the left. Remember, that's why we chose, what did we choose?
Left.
We chose, the shift is left. On the left of what? Watch this. It's on the left of our, where'd I go? Where's my thing? Oh. Look, don't pack up on me because y'all know how I get. Hit that doorknob. Watch this. Here's my, pay attention, baby. Here's my y-axis. Where's my vertex? Is it to the left of this line or is it to the right of this line?
The left.
So then that was a left shift. Does that make sense? Haley? Yes, sir. Yes, yes. This is to the left of this line. Is everybody following?
Mm-hmm.
Are there any questions on this? All right, great. Let's back up.